What's up, guys? It's our first video of the year. Are you so excited? And guess where I'm actually recording? I think this is my first time recording here. But can you guess? If you can't, look behind you and maybe you'll figure it out. We'll see if I fall out of this chair this time. I'm hoping that there are no chair incidents this year as I record videos. But we are recording this because I can't be there for A period today. So all of you in A period, hello. Give a shout out to Miss Kirk for covering for me and be good in chapel with her today, okay? For all the other classes, you're going to get this video too because why not? And today we're going to look at and talk about square roots. Now, square roots are not roots of a tree that are square. Believe it or not, they actually are something to do with math. So if you guys want to follow along in your book, section 2.2, sorry, I don't have the page number in front of me. I should have it. Hold on. I'll go get my book. All right, I'm back, and I got my stylus so I can write too. So we're on page 79. So go to page 79 in your books. I'll give you a second to get there, and you're going to follow along and fill in the blanks as we go. First of all, in words, you guys know what a square root is, but let's just review. A square root of a number is one of its two equal factors. So you know what factors are. 3 times 4, those are factors of 12. 7 times 9, those are factors of 63. But if the factors are the same, like 5 times 5, then the square root of 25 is 5, one of those two equal factors. So when you are multiplying a number by itself and you get another number, you take the square root of that number, you get one of the two equal factors. So in symbols, if x squared equals y, then x is the square root of y. And let's see here, here's an example. 5 squared equals 25, so 5 is the square root of 25. Now, a perfect square, and this will be important for you guys to know your perfect squares, is a rational number. Yesterday we talked about rational numbers. So rational means it can be written as a fraction, a over b. But any rational number whose square root is a whole number, so like not a decimal or anything like that, is called a perfect square. Okay? So for instance, 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. All of these numbers on top are perfect squares. So 25 is a perfect square. Its square root is 5. You guys can fill in the boxes. 36 is a perfect square because it's 6 squared. This is 7 squared and 8 squared. So it is important because you'll be using these a lot. It's important to know which numbers are perfect squares. So 1, 4, 9, if you can just recognize those as perfect squares, that's going to help you out with a lot of the things we'll be doing in this section. Now, another thing that's important to note is that every, and you guys can go to page 80 for this, every positive number has both a positive and negative square root. So if you think about it, 3 times 3 equals 9, right? So 3 is the square root of 9. But negative 3 times negative 3 also equals 9, so negative 3 is also a square root of 9. So technically, any number, any positive number that we take the square root of has two square roots, positive and negative of those. But keep reading, in most real world situations, only the positive, or what we call the principal square root, is considered. Now this sign, we call it a radical sign. That one generally indicates the positive square root. If we want the negative square root, then we'll usually have the negative in front. And if we want both the positive and negative, this one might be a new symbol, you might see both of those together, plus or minus square root of 5. So the way we would read this is plus or minus the square root of 25 equals plus or minus 5, or positive or negative square root of 25 equals positive or negative 5, however you want to say it. So again, there are technically two square roots, but this symbol means we're going to take the positive square root, okay? And there's boxes on page 80 for you to fill this in. So it's pretty basic. If we want to find the square root of a number, like 64, then what we need to do first is find factors of 64. And the factors of 64 are 1, 2, 4, 8, 16, 32, and 64. So you can list these in example 1. Now, which factor is a repeated factor? Well, if we think about it, 8 is a repeated factor because 8 times 8 is 64. So the square root of 64 is 8. You guys try the check problem on the bottom of page 80. So I'll give you a second to do that. So everyone should be doing this right now. What times what equals 225? Now this one is not one that we use often, so it's okay if you don't quite get it. It's going to be bigger than 8, right? Because 8 times 8 is 64, 9 times 9 is 81, 10 times 10 is 100, 12 times 12 is 144, 13 times 13 is 169, 14 times 14 is 196, I think. And then we get to the square root of 225, which is 15 times 15. So the square root of 225 is 15, if you didn't get it. If you look at the next one, this one actually is a decimal. Square root of 1.21 on page 81. But you can think of this as kind of the same as finding the square root of 121. So the square root of 121 is 11, because 11 times 11 is 121. However, it's 1.21, so we have to figure out where in our answer does the decimal point go. Now, there's two options. We could put it here, in front of both, or here. But if you think about it, when we multiply decimals, if I do 0.11 times 0.11, that would be 4 total decimal places, right? But our number that we're taking the square root of only has 2 decimal places. So it has to be 1.1 times 1.1 to have the decimal 2 places here. And again, the positive and negative, it's just the same thing. It just means that our answer is positive and negative 1.1 instead of just 1.1. So let's look at another example. If I want to find the square root, this time it says, again, find both square roots of 0.81. Well, that's the same as finding the square root of 81. So first of all, what's the square root of 81? And if you guessed 9, you guessed correctly. But this has moved over 2 decimal places. So would it be, well, in this case, there's really only one option. 0.9 times 0.9. 9 times 9 is 81. There's 2 decimals in our problem. So we would move our decimal over 2 places to get 0.81. So 0.9 would be our square root of 0.81 here. Negative square roots. If you look at the bottom of page 81, it says find negative square roots. It's the same thing, you guys. This is a pretty easy section. If I want to find the square root of 25 over 36, negative 25 over 36, we really can just find the square root of each part. So the square root of 25 is 5, square root of 36 is 6, but this negative just means I want the negative square root, so it'll be negative 5/6. So you guys do the check problem at the top of page 82. Take a second and do that. Negative square root of 49 over 64 is, I'll give you a second. If you wrote negative 7/8, then you are correct. Square root of 49 is 7, square root of 64 is 8. Now, until you get into more advanced math, for example 4, square root of negative 16 does not exist. So we cannot simplify this. This is not a real number. So we cannot take the square root at this point in time. No square roots of negative numbers. No square roots of negatives. They are not real. Square roots of negative numbers are not real. So when you see this, you could just say it cannot be simplified, or it does not exist, or something like that. But square root of negative 16 is not negative 4. If you think about it, what is negative 4 times negative 4? Positive 16. So is there any number that I can multiply twice that would become negative? No, because any positive times a positive is positive, a negative times a negative is positive, which is why we can't take the square roots of negative numbers. Okay, last thing for this section is that you need to, oh, actually there's a couple more things. Use square roots to solve equations. So first of all, we can solve equations by using inverse operations. Inverse operations kind of undo each other. So you guys know, like, if I was going to solve an equation like x plus 3 equals 5, to solve for x, instead of adding 3, we would subtract 3 from both sides, right, to get x equals 2. So subtraction is the inverse operation of addition. So the way we're going to solve equations with square roots, or with squareds, is to take square roots. If I want to find out if there was an equation like x squared equals 81 and I wanted to find out what that is, I would take the square root of both sides here. So if I have x squared equals any number here, then we're going to square root both sides. Now technically there will be two solutions then, the positive and the negative. And let's just look at an example. This will make more sense with an example. So here, t squared equals 169. If I want to solve this equation, again, solving equations means we want the variable by itself. So if t squared equals 169, then I'm going to square root both sides of this, okay? But important note, important. Whenever you square root both sides of an equation, there are always two solutions. How many solutions? Two solutions. How many? Two. So on the left, the squared and the square root cancel each other out. And we just have t. And the square root of 169 is 13. But it's also negative 13. So in this situation, even though we're square rooting in this symbol, we normally want the positive. When you are solving an equation, there are always, how often? Always two solutions. So make sure you get both of those solutions when you're doing that, okay? All right, look at this next example. This one's not in your book. You can write it down if you want. But if I want to solve this equation, m squared equals 0.09. And then again, we're going to square root both sides. What is the square root of 9? The square root of 9 is 3. But in this case, it's going to be 0.3 because it's 0.09. So 0.3 times 0.3 is 9, and I'd have to move the decimal over 2 places. So that would be 0.09. But it's not just 0.3, it's positive and negative 0.3. So two solutions when you square root in an equation. Sorry, this is not working very well. Okay? Alright, a couple more things. We have not only square roots, but there are cube roots. Not only can they be square, but they can be three-dimensional cube roots. So if a square root is two repeated factors, then a cube root is a number that has 3 equal factors. So in symbols, we would use, instead of the square root symbol, the radical symbol, we just have a 3 with it outside to show that it's a cube root. You can actually have 4th roots and 5th roots too. You would just change that number in front. So 2 cubed equals 8. So 2 is the cube root of 8 because 2 times 2 times 2 is 8. Now with cube roots, we can have negatives. You can take the cube root of a negative number because a negative times a negative times a negative is also negative. And there are some perfect cubes that you should be familiar with. So here, really quick, this is on page 84. There's some boxes you can fill in. The cube root of a positive number will always be positive. The cube root of 0 is 0. That should make sense. And the cube root of a negative number will always be negative. Because 3 times 3 times 3 is 27, but negative 3 times negative 3 times negative 3 is negative 27. And I want to hurry this up because this video is already way too long. Alright, so perfect cube. You guys can fill this in. 1 cubed is 1. Negative 1 cubed is 1. 2 cubed is 8. Negative 2 cubed is negative 8. and so on and so forth. So in this case, there are positive and negatives, and the cube root is just one thing. So when I take the cube root of something, there's always only one. With square roots, technically there's two. With cube roots, there's always only one answer. So if I want to simplify a cube root, and again, just really quick, the cube root of 125 is just 5, because 5 times 5 times 5 equals 125. The cube root of a negative number, like negative 27, is just a negative number itself. What number multiplied 3 times equals 27? 3, because negative 3 times negative 3 times negative 3 is 27. Okay? And we could do the same thing with equations. We can actually solve equations using cube roots. The same way we do with solving equations with square roots. And I'm just going to do this quickly. If you don't get them all on the homework, that's okay. We'll talk about it more in class tomorrow. But we can actually take the cube root of both sides. And in this case, there's only one solution. So the cube root of 125 is 5, and the cube root of 8 is 2. So just like we can take the square root of both sides, we can take the cube root of both sides. And I will stop now because this is taking way too long. Your homework for today is worksheet 2.2, the whole thing. Good luck, and we will go over any questions tomorrow.